All right, so I think we're recording, and this is the first lesson for the trig portion of the pre-calc class, September 14th, and we're looking at section 1.1, learning about angles and special triangles. We've done some special triangles in the past, so a little bit of this is a review. From the beginning, you're going to see topics that you've seen since pre-algebra, and so I'm going to go through these very quickly until we get to new stuff and then slow down a little bit. But for the beginning, you have angle types. Acute angle is going to be between 0 and 90 degrees. Right angle is going to be 90 degrees. Straight angle is 180 degrees. Obtuse between between 90 and 180 degrees. Complementary is where they're going to add up to 90 degrees, and supplementary is where they add up to 180 degrees. I'd say out of all those, the two you probably want to focus on would be the complementary and supplementary. Don't get those names reversed. In trig, you're now going to have angles that are positive angles and negative angles. That's new for you. So in this particular angle, you're going to see you're starting with side OA and going to side OB. And that's indicating that it's going to be going in counterclockwise fashion. That means when it's counterclockwise that you're going to have a positive angle. It's not going to make sense to you today on what's the relevance of a positive or negative angle, but it will in the future. So just know when you're dealing with a counterclockwise angle, it's going to be positive, and if it were reversed to a clockwise angle, going from this OB to OA rays, it would be a negative angle. So you have positive and negative angles depending upon which way your angle is going. You know also that this is an initial side and OB would be the terminal side. So we have names of the starting ray and the finishing ray. The concepts, we're going to be looking at Greek letters of the alphabet. You have alpha, beta, and theta. The book uses these Greek letters to indicate angles. So instead of X and Y, they're going to use these symbols as missing angles. Just want you to be familiar with them. And often you see those same symbols in like Greek letters, fraternities and sororities. But the reason why they're Greek letters is because the Greek mathematicians developed a lot of these concepts, and so that's why they're pulling these Greek letters out. Some of you have these big rocks in front of you, these sheets. These are the main concepts that we're going to have per chapter. This is for the whole book. So the first page is just the main concepts for the first chapter, and you would fill this out and study it for the tests. A lot of you probably don't have the best study skills for math, and this is a way to organize your main concepts per chapter. And make sure you get these concepts down before you start diving into the problems. So you're going to be filling this out along the way, and you can even see you have special right triangles in the lower right. You know what that's all about already, so you can fill this out later or as well. Going ahead, we have the Pythagorean theorem. Pythagorean theorem we've had since algebra. This is the leg squared plus leg squared equals the hypotenuse squared, or a squared plus b squared equals c squared. C squared has to be the hypotenuse squared. So at this point, we've spent about 5-6 minutes on solving this triangle in class. And so I want to go through and do this quickly and show you some algebra errors that probably occurred while you were doing it. first of all, we want to write the problem down correctly, so we don't make a mistake off the front end of it. And we want to square each of these. Notice that you're squaring x plus 7 quantity. And we're very clearly up front showing that I have to square each of those particular sides. Then what I want to do is remember that x plus 7 squared is x plus 7 times x plus 7. I write that out because it's going to remind me that I have to do 4 multiplications, and students will want to do the easiest thing, which is, oh, well, why don't I just distribute that power through? You can't distribute the power through. If you write it out like it's supposed to be, you can see that you can't just distribute the power. You have to use FOIL. You have to do the 4 multiplications or distribute twice. So this is going to end up being this, and you're always checking that middle term, 14x, 7x plus 7x is 14x. Now what you want to do is combine, simplify, and because you're dealing with the square, a quadratic, you want to factor first. Always try factoring before you go to anything else. And at this point, I want to get rid of the 2 because it's in all terms. If I divide out a 2, I now can make this factoring even easier. Get the parentheses down. 1 has to be plus and 1 has to be minus because that's a negative, and you're left with 12 and 5, meaning x can equal where the first term can be 0 or the second expression can be 0. So x can be negative 12 or 5. And then you take those answers and you see, do they make sense? Well, if I plug them in to this problem, you're going to see x has to be positive because it's a length. So I'm going to cross off the negative 12. Doesn't make sense in the problem. And then my answer is going to be x is equal to 5. Now, in this course, you're going to see that it's going to reward you if you memorize topics. All of your algebra or math classes before, your teachers probably said never memorize, understand why it's the way it is. And that's a good point. However, in this class, if you're always concentrating on understanding the concept, you're going to have a frustrating time because you can't do things as quickly as you should. And time will be important in this class as well. So I'm telling you, it's okay to memorize. But we will always develop the concept, but then we want to memorize that concept and use it. For example, one thing that you should memorize are the Pythagorean triples. Pythagorean triples are sets of numbers. When substituted in, they complete the Pythagorean theorem. One Pythagorean triple is a 3, 4, 5 triangle. A 3, 4, 5 triangle will satisfy the Pythagorean theorem because 3 squared plus 4 squared equals 5 squared. If you knew that one leg is 4 and the hypotenuse is 5, you would automatically know the other leg had to be 3 because they're in the right location of that triangle. The problem that I'll see at times is if I have a 5 for A and a 4 for B, some students will want to put 3 in for C. That's not the longest leg. It's not in the right ratio. You can't just throw that number in. It's call it good. They have to be in the right location. Now, 3, 4, 5 works, but also multiples of 3, 4, 5 work, such as 6, 8, and 10. 6 squared plus 8 squared equals 10 squared. Any multiple of those numbers work. There are 4 total, and these will come up on ACTs, as well as in this book quite often. And again, if you can avoid doing the Pythagorean theorem, you're going to want to do that. What's the next one? 5, 12, 13, 8, 15, 17, 7, 24, 25. The first two listed come up most frequently. And again, this just isn't in this class, this is on standardized tests. Good things to know and memorize. Questions on that? Yes?
Is it always like the multiple of like 5, 12, 13 too?
Yes.
Okay.
Any multiple of any of the four would work. Absolutely. On this slide, you're going to see stuff that we've already done. This is all special right triangle stuff. And so you may not have to write it down if you know it already. It's simply how do you get to 45, 45, 90, how do you get to 30, 60, 90, and then what to remember. You're going to remember on the 45, 45, 90, you have ratios of 1, 1, square root of 2. On the 30, 60, 90, you're going to have the ratios of 1, radical 3, and 2. Know where you're multiplying. 1 to 2. 1 to radical 3. And then you're dividing going in the reverse direction. We've done a lot of work with these triangles. I'm assuming that we're comfortable going between, given one side of either of these, how do you get the other two? Just by multiplying. We don't have to use the Pythagorean theorem on these anymore. We know the ratios, we use them to do things efficiently. I'm going to go ahead, if you need more time on this slide, I'll go back to it, you can copy it later. The last thing that I want to show you is just a couple ideas on the homework that they're assuming that you know. One question that comes up is, for example, complementary. If you know that one angle is 20, what's the complementary angle to 20? 70, how do we get it? 90 minus 20. How about 10? Complementary angle is 80, how do we get it? 90 minus 10 is 80. What about it gives you a variable like y? What would be the complement of y? 90 minus y, and that's it. Don't even worry about putting any numbers in. So that's one question that you're going to have in your homework. The other question deals with parallel lines and angles. If you have parallel lines, assume that you remember this from geometry, that those angles, and let's say alpha, well, let's say theta and alpha, using those new Greek letters, what's the relationship between theta and alpha? They are corresponding angles because these are parallel lines cut by a transversal forming corresponding angles, and I know that corresponding angles are in fact equal. This will be one part of a question that you've got to remember. That concludes the first section in the trig book. I just have to figure out how to turn this thing